Alrighty, let's implement find on our BST class. So the first thing we'll do is just add the method find, which accepts a value. And we have a couple of optimizations we can make at the end, but I'm just going to start by following this. We're going to check if there's a root. So that's simple. If this dot root is null, then we're just going to return, what do we want to return? Undefined, false. Let's just say we want this to be true or false. So we're going to say that it either returns true or false. So if there's nothing in there, then we can't find the value, so return false. That's nice and easy. If we run it, we make a new tree. I'll call it T, new binary search tree. If we do t.find1, we should get false. All right, so that's out of the way. Now what I'm going to do is make a variable called start. And I'm going to have start equal the root. You could also call it current. I kind of actually prefer current. So I'm not going to call it start. I'll go with current. And then let's make another variable. And this one is going to be called found. And it starts as false. So found just keeps track of if we've found the item yet. Then we need to get to the bulk of our logic, which involves basically looping. So I'll do a while loop. And we want to loop while not found. So while we haven't found the thing, but also while there is a current. So I'll explain why in just a moment, but we want to keep going because if let's say we never find it, right? It's not in there. Found is always going to be false. So we also need to make sure this loop doesn't go forever. So current is going to be our value that as soon as there is no current, whenever there is, we've hit the end of the tree, we can't update current, it's null, then our loop will stop. So basically this is while there is something to loop over and we haven't found it, what do? Let's start by just checking if the value is less than current dot value. If it is less than, then we're going to say current is now equal to current dot left. We know that it needs to be on the left side. So for example, if this is a tree we have and we're looking for 2, well, if we did a tree.find2, we're going to set current to equal this node, and then found is going to be false. So we check. 2 is less than current.value. That's true. So now current is this. And so we start again. So let's do the same thing with an else if. Value is greater than current.value. If that's the case, current equals current.right. Now we're missing the most important part, which is the else. If we found it, we're going to set found equals true. So this is if it's less than, this is if it's greater than. The only other option is that it's equal to. So we'll set found to true, and then the loop should be done because this is now false. Not found, not true is false. So we're done here. Then after this while loop, we need to return the node. Well, I was pretty unclear about this, honestly, in the instructions. I regret that. If you should return the node itself or return true or false to see if it contains it. Let's return the node. So that's going to be current. I apologize if you implemented one solution and I did the opposite here, but the logic is the same either way. We could return true right here if we found it. We can return current. Okay, so I'm going to return current at the end. And then we also want to check if it's never found, we should return something. Because right now, oops, did not mean to do that. If we run this code, we've got our tree. What values does it have? It has all of these. So if I look for, tree.find 5, for example. Okay, it was in there. Tree.find 10, that's in there. Tree.find this time 2, that's also in there. Okay, but what about 100? That's not in there. So we're getting null. Instead of null, I think it would be better to return false. So to do that, we could add just an if statement here. If it's not found, return false. Or actually, I think undefined might be better. It doesn't really matter, but just some value here to indicate it's not in there. And if we wanted to, so just to be fair, if we wanted to do the true or false version, so it doesn't actually return the node, it just returns true or false. So maybe I'll call it like contains value. It's a little simpler because if we find it, we can return true. Then we don't need this here. We can just return false. Okay, so if we find it, if it's equal, we return true. And then the only way we get here is if it's not in there. So we return false. So if I run this one, we do tree.contains 1, that's false. But 10 is in there, so is 2 and 16, I think. But 18 is not in there. Okay, so sort of out of left field, but I decided to do 2 implementations. One, true or false only return values called contains. The other one is called find, and it actually returns the value, the node itself, if it's in there. Okay,